quizzes and whatnot based on the stuff we did and some stuff that we probably gonna go over today. All right. So what I'm gonna do, I'm gonna log in the Canvas and go to the different modules. All right. All right. So I added some modules. I added a quiz, that variable name quiz, right? Remember we talked about valid variable names, right? Or user defined variables, right? Or user identifiers in the program, in the compiler. So you got to know how to create variables. You know, what was the rule? What was the 3 rules we talking about?
No special characters.
No special characters.
No space.
No spaces, one word, or
Don't
whatever.
begin with a number.
It cannot begin with a number, right? And we know we can't use any one of the reserved words, right? Or those words that are already defined within that compiler. All right, so what I did, I've added 2 string programs. These string programs, these programs were given to you for you to kind of understand how the escape sequences work. Remember we looked at that little chart where it had the \A, I think R, \N, \T. That particular chart, that's escape sequences. It looked as 2 characters, but it represents 1 character. Now, remember I told you if you wanted to print out 1 backslash, not a forward slash, a backslash, you would have to what? In double quotes print out how many? Or specify 2, correct. If you wanted to represent 2 backslashes, then you would, consecutive, you would have to do what? 4, correct. Because each one signifies, okay, the escape, first one, escape sequence, okay, what's next? Oh, a backslash, right? Remember how I did the \N and the \T? Okay, the backslash, oh, what's next? A N. What that means? Return to a new line, correct? If I do a \T, it says, okay, backslash, what's next? T. Oh, tab over, all right? So everybody understand that? So these programs, I'll let you see the first one. The second one is similar but a little different, you know, output. If we look at this, wait, oh no, scratch that, further down, the escape sequence program. This is a string program, all right? Let's look at the escape sequence being that we was talking about it, so you won't get confused. All right, I think I got the escape sequences module. All right, thought I had escape sequences. Right, let's look at the escape sequences, all right? Here's one of them. All right, look at this. This, when you look at this here, double quote, now, don't worry about the double quote going left or right. You know, that's something with Word, right? When Word have an open one, then it has a closed one. But when we dealing with just like a straight text, you just have that double quote. So don't worry about it going left or right, right? Just a double quote. So when you look at this, it says write a program using one cout statement that will output the following. Double quote, all right? Backslash, %, double quote, bears, all caps, double quote, slash, %, double quote. So all you're doing is trying to use what? Escape sequences where they are needed, right? So now you need to just know where the escape sequences are needed, right, class? To create this output, this exact output. Don't come and say, well, Mrs. Vester, I thought the double quotes was just signifying what you wanted outputted. No, that is the output. Everybody got that? The double quote should be outputted also. Everything you see there. Any questions? Questions? All right. So let's look at the second one. I think I could do next. I think. Yeah. Look at the second one. Similar, but just a different output. Using a single cout statement, write the C++ program to produce the following. Double quote, pound sign, slash, slash. All right. Single quote, Baton Rouge. All right. Slash, slash, space. Well, it was backspace, slash, slash, space, and space, backslash, backslash, space, Rouge, single quote, backslash, backslash, pound sign, double quote. Everybody got that? This here is a single quote. This here is a double quote. Everybody understand the difference in the two? Okay, all right. Any questions? Questions? So all you're doing is creating your shell. Now, I do want, remember I told you, I do want that .h file associated with this program. So what? That .h file that's gonna have your name, the course, my name, and the due date, right? All your programs, I want that in there, right? So you're gonna have that function in there, in that .h file, and you're gonna call it from that program. Everybody understand it? Questions? Everybody see the due date, son? When they do? Tomorrow, right?
Yeah.
All right, so if you got any questions, I'm here in class today, right? Don't leave here, well, Mr. Bester, I didn't know what to do. Hey, we're in class, right? You ask your questions. Now, I assign the programs thinking hopefully that you would actually attempt to do them, and then you come to class with questions. But if you wait till the last minute and you get stuck, there's nothing you can do, basically. You can email me late at night, might answer it if I'm up, you understand? But if I'm not, it's like, okay, well. All right, so that's the two programs dealing with the escape sequences. All right, so now let's look at the string programs. All right, so I gave you two string programs. If you look at this program, all right, and we kind of talked about string, we got into string, and I'm gonna pull this up. It says, and you got to follow the instructions, class. You might be able to write the program in your way and it works, but if you don't follow the instructions that I have, you're not getting the gist of the assignment. So this says write a C++ program that will declare an initialized variable, it should be variable, for each question listed below. So you're gonna create a variable for what? You got a question that's saying, what is your name? So you're gonna create a variable for name. You got a question that says, what city do you live in? So you're gonna create a variable for city. Everybody understand that?
Yes, sir.
But now, what it says, you're gonna give it the value at the beginning of the program. You're gonna initialize it. It's kind of like saying int x equal 5. So when you first start, you're telling it what the values are. Everybody got it?
Yes, sir.
And then you write the code to output it in this manner. And I want it just like this. Hello, all right, comma. Okay, and just skip to a new line. My name is whatever name that it was initialized to, period. I am from whatever city, comma, and state. And I want it in that fashion, city, comma, space, state. All right, so make sure it's like you writing the paper, that all your spacing and punctuations are in order. Everybody understand it? All right, blank, all right, is my major, all right? I plan to, I missed this one. Baton Rouge, let's see, where is that? I enrolled at Baton Rouge Community College in whatever semester, whatever year, like fall 2009, to right now, spring 2020. Everybody got that? I plan to work as a, and like I said, I could have put a parentheses and, but don't worry about it if it begin with a vowel, you know, as a, and you can say technician once I have completed my studies. Questions? Anybody have any questions? You're going to declare the variables, the value of the variables, right? And then you're going to write the cout statements to output it in this fashion. I don't want no one long line, my name is whatever, and I got to scroll all the way across the screen. My name is whatever I am from the city, state, I enrolled at, then new line, BRCC, everybody get that? That's how I want it. All right. Now, look what it says. Let me just remind you. Variables must be declared as strings, all right? Because it's more than one what? Huh? More than one what? Character. A character string, all right? I mean, well, a string, right? So now, it also gives you a hint. If you use string, you know, when you declare your variable, you will need to use the string header file. File includes string. So if you don't read through all this, you'll be trying to work on this and maybe running into issues, all right? Everybody understand that? All right? So that's one of the string programs, all right? So let's look at the next one. I think it would be the next one. All right, string program 2, all right? Exact same program, but you're writing it in a different fashion. Now, we should get to this in the lecture today. And the thing is, it says, write a program that will prompt the user to input answers to the following questions. Now, did it say to declare them and give it a value? Huh? No. So in this program, you're not giving name a value at the beginning. You're not giving city a value. You're allowing the user to do what? Huh? Input from the keyboard. All right? Now, and we'll get to this in the lecture. The reason why, it says do this. Research the get line command to correctly display entries with spaces between words. Example, Port Allen. Port Allen is what? 2 words, right? You cannot simply do a CN to input a string with spaces in it. It's just going to accept from the beginning up to the space, and the next part going to go to the next variable. You're going to run into problems. So research the get line command. Everybody got that? All right? But now, I gave you an example down here. Look at this. Sample command, get line, then an argument, CN, comma, what? Name. So if somebody put in a 2-word name, it should accept name from the beginning all the way to the what? To the enter key, where they hit enter. Everybody understand that? So you're writing 2 programs that are identical in a sense, where one, you're giving the value, declaring and initializing the values, and then when you run it, you'll get the same thing every time you run it. And then you're writing the second program to allow what? Any user to type in their information, and then it should give it back to them in that fashion. All right? Everybody got that? Questions? Questions? All right. But like I say, you got all this in red. It tells you, okay, remember you need to do this, because you're going to run into a whole lot of issues, all right? Output, basically identical, right? Right? So once the data is inputted, same particular output, right? Exact same output, all right? So, now, what's the next assignment that I put out there? All right, here we go. I gave you an assignment of 20 C++ commands or keywords that are used in C++. What's one of the words that we use always, or one of the commands we always use in C++? C out, right? So C out is a command that's in C++. All I want you to do is list them by numbering them and like say telling what it does. C out what? Outputs information to the what? To the console. You got it? So look up keywords in C++ and then choose the ones you want. All I'm trying to do is get you to see the list, but then turn in an assignment with 20 of them. And at least you'll kind of remember some of them and maybe look at and know what they actually do. All right? All right, so when you look at this, not this one, the 20 one. You understand? So, commands, this is an example of your assignment. There's gonna be a document assignment that you gotta submit back to me through Canvas. Commands, C out, but then you have the next one, the next one, the next one. The purpose. Now, your purpose would be on this side, used to display the output to the standard output device, i.e. the monitor. All right? So that's all that command does. Right? I don't want no drawn out paragraph research paper on that command. I just want the simple purpose of that command. Everybody understand? The multiplication symbol is not a command, that's an operator. Double quote is not a command. You know, that's part of the syntax of C++. You understand, like when you have to enclose something double quote, the worded command, and then you're gonna notice all C++ commands are in lowercase. All right? Yes, sir.
Do preprocessor directives count?
No, but the include, you understand the word include count. Right, correct.
Like not define or?
No. Yeah, well, define would count because define is a word that's reserved, keyword, but you define a user-defined function after that or process. You know what I'm saying? Right. That's like pound include. Pound include. I don't want you to have vector, file, F stream, and all that. You know, I want include. Include is the catalyst of that. Okay. All right. All right. So that's that assignment. Now, then we have two programs. All right. Now, you should be somewhat familiar with writing code from the previous class and somewhat what we've done in this class. And like I say, I'll entertain questions if anybody have any concern. Now look at this. This says write a program, write a C++ program, given the length 73 and 49 inches. Everybody with me? Convert the number of inches, all right, of the two distances to feet and inches. All right? Example, if I had 13 and 3, all right? 13 and 3 is what? Huh?
16.
If I wanted to convert that to feet and inches, that would be what?
1 foot.
One what? 1 foot, 4 inches. How did you get that? You understand? So you're gonna have to come up with that process of how to determine it. Everybody understand that? I don't want you to just put in, oh, it's 10 feet 2 inches, so I'm gonna just see out 10 feet 2 inches. You're gonna calculate. You're gonna add the two together to get 121. Then you're gonna have formulas or a formula to calculate the feet. Then a formula is to calculate the inches. Everybody understand what I'm saying? Huh? You don't get it, Mr. What?
Nihat.
Huh?
Nihat.
Nihat. Okay, let me ask you this. Mr. Nihat, you know how to use a modulus function? Modulus. I mean what a modulus operator. You know what the modulus does?
Yeah, like break it down.
It break it down.
No, you said, no, I don't know.
Modulus. If I said 12 modulus 16, well, not that, 16 modulus 12, what that equal to? What's 16 divided by 12 for getting the modulus? The modulus gives the what class? The remainder. What's 16 modulus 12? Huh?
Well, you said 16.
The remainder. 16 modulus 12. When I divide 12 into 16, I get what? With how many remainder? Huh?
One.
Huh?
One. I don't know.
How many 16 is from 12?
Six.
It's 4. Look, 13, 14, 15, 16. Look. All right. I have something like x is equal to, and they can't see it on the thing, 16 modulus 12. So that's something like this. 12 going to 16. That's 1, right? With a remainder of what?
4.
So what's the modulus? X is equal to what?
4.
Right. That's what the modulus gives you. Everybody understand that? Right? Now, but looking at this, how can I get this? How can I find this if I do this? If I do int x, and then I'll say, let's say, and x is x equal, well no, int x, all right, and then I'll say int y is equal to 12, y is equal to 12, and I do something like this, what I get? Oh no, I'll put y. What I'll get here? What's x?
16 divided by 1.
16 divided by what? Which is what?
12.
Which is what?
X equals 16 divided by 12.
Giving,
1 with a remainder of 4.
giving,
1 with the remainder of 4.
giving. Giving what? 1, integer. Remember we talked about that? It only gonna just give you the integer. You understand where I'm going? You wanna find the feet? You wanna find the inches? You got what I'm saying? Right? One of them you're not caring what the inches are, right? And then the other one you're not caring what the feet is, right? Because you already calculated whatever, right? And then you put the two together, whatever feet, whatever inches. Everybody got that? Notice I gave you the two distances. So you're gonna use those distances. Declare them to be equal to that. Everybody understand that? Okay. All right. So the next assignment, all right? Now, we as computer scientists, we should be able to take, and we're going to go over that in the chapter, take an expression, break it down, and represent it in the program. All right? So, in math, 2a is equal to what? If I have to write it out, 2a is equal to what? If I have to write that expression out, 2a is really equal to what? 2. If I wanted to solve it, 2a is equal to 2. Come on, somebody.
Oh, 1.
No, I don't want the value. I want to know the process of what I need to do. 2 what?
2a divided by 2.
No, I don't want the actual result of that. I want what I need to do. 2a, what I need to do. No, you don't. 2a is 2 times a. 4b is 4 times b. 3ab is 3 times a times b. You got what I'm saying? Everybody understand that? You see where I was going? All right. 5a is 5 times a. 2b is 2 times b. Right? Everybody agree to that? So, what happens is, we have this program here. Well, not this program. We have this expression, and it says solve. Now, what's the known? Those constant values: 2, 4, 3, 5, and 2. What's the unknown?
A, B.
A and B. So what you're gonna do, you're gonna write a program giving A a value, and giving B a value, and then solving the expression. Everybody understand? But now what? You're gonna have to say A is equal to whatever, int A is equal to whatever, int B is equal to whatever, right? But then in your expression, results is equal to 2 what? 2 times A minus 4 times, you understand what I'm saying? So you're going in and solving it based on the numbers that you give it. Everybody understand it? Everybody got it? And that's all that's program doing, kind of getting you to understand, okay, I have an expression here. So how I write it out in the computer to solve for it. Everybody understand it? And that's all the assignment, right? When it's due? All right, okay. Everybody got that, right? Don't forget. Oh, Mr. Vince, I fell asleep. Oh, Mr. Vince, my job. All right? Okay, any questions? All right, no questions. All right, so let's look at the notes. I didn't want to do that. No. All right, so now, in chapter 2, remember, we kind of looked at these special characters, right? The double slash does what? Comments, right? Remember that? Right? The pound sign, that's for our what? Our preprocessor directive, right? And then we enclose whichever library we're gonna load, right? With these symbols here, open and close braces. Parentheses for those arguments that we may have an argument list, or we might not have arguments, but we need them. Or like we never got that if statement, you gotta group your condition. All right, you open and close curly braces to define the body of your main, of an if, etc. And then your double quotes over your string, right? Whatever your string value is or whatnot. And then the semicolon is used to end certain statements in C++. All right, so we went over that. All right, so we looked at this program. All right. All right. Now, here in your program, here we go. What are these, class? Escape sequences. If I want to print out 1 backslash, I have to use what? 2. If I want to print out a single quote, I have to use backslash single quote. If I want to print out a double quote, what? Backslash double quote. All right. Now some compilers recognize a single quote without the backslash. Different compilers work different ways. All right. If I wanted to have an alarm like a ding or whatever, like you hear a lot of times with Windows, you can do \A any way you want in the program, and whenever it hits it, it'll actually put out a sound. All right. So these are some of the escape sequences. All right. And I gave you certain ones to use in your output. All right. Now, the preprocessor directives, we pretty much know that. We know the program. We know how to write a program. Variables and literal. Okay. Int, number. Okay. That's number is a variable. Correct. What's the value? It has no value. Correct. But when if I say int number equal 5, now I'm doing what? Initializing it. I'm giving it that value when I introduce it to the compiler. That's called initializing. Okay? There's a difference between initializing and assigning. Assigning would be the variable is already declared, but then later on in the program, I'll say number equals 5. That's assigning. I'm taking that value and throwing it into numbers, right? But it's already reserved, have a reserved location in memory. So the computer know where it is, what's the data type, etc. All right? But that's the difference in the two. All right? So here, int number is equal to 5. And what we doing right here, we said? What we doing at this point?
Assign.
Assigning. If I'd have said int x equal 5, I would have been doing what?
Assign an X.
I would have been doing what? Begin with an I.
Initial.
Initializer. You understand the difference? Here, I'm giving it the allocating that, telling that it's integer, and I'm introducing number, and I'm giving it a value, right? The data type, the variable, and the value. Here, it's already allocated in memory, okay? And now I'm saying number equals 5. So now that's assigning, okay? So that's that. All right, and then it outputted number. If I put double quotes around number here, what it would print out? Huh? It would print out the word number, because I'm saying I'm printing out what? A string. All right? You gotta be aware of that, because some of y'all gonna run into those issues when y'all program. All right, so it says here, sometimes a number isn't a number. Now, what does that mean? What that means is, if I put a number in double quotes, or even a number in single quotes, then that number becomes a what? Either a character value or a string value, right? Because numbers can be considered as character data, right? When I do an address, like a street address, numbers is included in that, right? Hello, Miss Ashley Frierson, all right? Numbers is included in that address, right? So the numbers can be considered part of that address, that character data, right? So if I said I wanted to output the number 555, okay, well, just say 555, I could initialize it to int and print out 555, or declare it to be int and initialize it and print out 555, or I could declare it to be string and put double quotes around it and print out what? 555, right? What's the difference in the two? Huh? Huh? One is a value, 555. The other one is just a string, what? 555. You got what I'm saying? One of them I could take and put in an expression and multiply 555 times 2 and get, a result that I know of. The other one, I'll have a string, I'll multiply it, but I'd have to go to the ASCII table to figure out what my value is. You understand what I'm saying? All right? So that's the difference. All right? So like I said, you gotta watch when you're doing that. All right? So that's all it basically saying in this section. Numbers sometimes are not a number. Okay? What is this, class?
Keyword.
Keyword. Hello. So on the weekend, if you just went in the chapter and look what else, man, I'm doing my homework now. All right? So these are keywords that you can look up and you can try to find, well, you can find what they are, what their purpose are in the compiler. Right? Hello? And that I only want you to do 20, right? I could have said do all of them, right? But then I'd have to check all of them, right? So I want you to do 20, okay? All right. Everybody straight with that? All right. All right. And remember, variable names, I cannot create a variable called float. I cannot create a variable called operator. I cannot create a variable called else. Any one of these reserved keywords I cannot use as a variable for myself. Everybody understand that? They already have meaning within the compiler. All right. So now, we talked about this already. What is a valid identifier? One word, doesn't begin with a number, and what? No special character. Right? So we know that. Right? Everybody know that. But like I said, read through your chapter. We going through the chapter, kind of like touching on whatever, but I want you to read through the chapter. Right? Now, these data types, remember we looked at the SYL site when we looked at the different data types, and I'm telling you short and then int, but then look, it breaks it down more. Short int, unsigned short int, long int. You understand? So you can have, and then you got long int, different data types, so that you can what? Have different range of numbers, right? Right? And like I said, it might not be useful to you now, but as you become a more and more experienced programmer and you start writing and developing software, you want to use as less memory as possible so that your program can load quicker, run quicker, and give you output quicker. All right? All right. So now he's just talking about the different ones, signed, unsigned, whatever. All right. Now, so here, if you look at this, it said long days. Long days, days is just what data type? You know what the actual data type is? Int, right? It just have a certain range, right? Everybody understand it? It have a certain range, all right? So that's what it's saying. Now, so that when you use your different data types, and like I say, you can increase the size of the values that you can use, or have a certain value range you can use, or you can have the lower ones like short and have a minimum size. All right. All right. So it said this program here has variables of several of the integer types. Okay. But because listen, what happens with the data types is, and I could write the code for you. What happens if I have something of int, all right, not int, I'll say short, and I go beyond the limit of the short value by 1, what happens? Huh? It what? It will work. Why? Huh? What would happen? All right, let's go to our table. So what's the largest value that short can have? The largest positive value.
32,700.
All right. So if I add 1 to that and try to display that short value, what is it gonna print out?
Error.
Nope. All right.
767.
Huh?
32,767.
Nope. Let's look at it. Let's do the experiment. All right. So what I'll do, all right, I'll go here and we'll write the code. All right. We'll go to online GDB and we'll just write the little short program, and I'll let you see exactly what happens. Because sometimes when you tell students like, oh, how that, okay, it's because of the byte size. All right. It can only hold a certain value. So if I do pound include IO stream, all right, so we have this. So I'll say short, I'll say number, all right, equals, it's not time yet, huh? Okay, all right, something to take care of. Let's take care of my assignment. All right. All right, number, and I'll say 32767, right? That's the largest value, okay? So now, I can do this. I could say number is equal to number plus 1, all right? Or, this is the short way. I can say number plus plus, all right? What does that do, class? It increments it by 1. All right, all that's saying is number is equal to number plus 1. All right, but we'll get to those pre and post operators after a while, or later at a later time. Now, what I'm gonna do though, I'm gonna do a cout number to show you what the number is, and then I'll do the same thing here. All right. So after I increment it, I'm gonna print it again, right, class? So let's run this. All right. So we're giving it the maximum of the shorts value. Then we're gonna print it out. Increment by 1. Then we're gonna print it out again. So let's run that and see what happens. What happened? Okay. All right. So let's look at our table. What happened, class? The largest value is what? 32,767, right? We added 1 to it and it gave it the value what?
Negative.
Which is our what? Which is our what? Look here. Which is our lowest value in our what? Range. So what happens is it cannot go beyond that value. So what it is, okay, 1, it goes back to the beginning and goes back to that first position, that number. And if it's 2, it goes to the next one. If it's 3, it goes to the next one and goes up higher. Right? Now, does that mean your calculations are wrong? No. It just means that the data cannot be represented in the right fashion because we told it to put it in those 2 bytes. Right? Because if I go here and if I do something like this, num plus plus, and then I'll say int x is equal to number, right? And then I'll take this put it up there. All right, then I'll say I'll change this. Change this to x. Change this to x, and when I run it, oh, it gave me the same. Oh, no, x is in. But I gave it. X go down. Oh, that's because it's in there. It's in that 2 byte position. So it only can send the 2 byte position. All right. So, all right. Change this to int. Wow. That's right. Because it's a short position. So if I do that to int, then it's going to run the program giving me the higher value because it can store it in whatever. So see here? So it gives me the value. So what I was trying to do, grab it from that 2 byte position, which it can only give me that value, right? That from that 2 byte location. All right. So the answer your calculations is right. It's just that it cannot represent it in the proper fashion because it can't store that large value. All right? Everybody see that? All right. So now, so that's the ranges. Let me close this. All right. So here we go, and this shows the program where it's showing the values of this. All right, because they're different sizes, and they go over the different sizes, kind of like what we did. Small program. Now this program allows you, or if you look at the program that I gave you with the names, this example should help you to be able to write out your string, then stream whatever your value, stream whatever your string, stream your string, stream your value. So you should be able to look at that as a pattern as to how to format for my name is whatever. I enrolled in Baton Rouge Community College on whatever, right? So that should kind of give you a guide, okay? Integer and long integer, all right? But like I said, all it is allowing you to have numbers that are a higher range. But it's telling you there's different ways you can do it. Long amount, or you can do something like this. Amount 32L. So that's saying store that 32 in amount as long integer. All right? So you got different ways you can write your code. And all that's programmer style too. Some people do it this way. That's their programmer style. All right? Look here. Long amount. Amount equals 32. LL, long. All right? So that gives you an example. So it's saying if you want an integer literal to be treated as a long int, you can append the LL at the end of the number. And that's all it's saying. All right? All right. Now, Hexadecimal. What's hexadecimal? How many digits is hexadecimal?
Six.
How many? How many? 16, class. Right? Hexadecimal is 16. What are those digits? What are those digits for hexadecimal? Huh? I can't hear you. Huh? That's just 2 digits. That's binary. What are the 2 valid digits in hexadecimal?
One's 15.
Huh?
Zero.
Huh?
Zero.
08.
0 to what?
8.
0 to X. Okay.
Zero to 15.
0 to 15. Huh?
16.
Zero to 15.
The digits. What are the valid digits?
0 to
0 to 9.
18. Okay.
And what?
8 to F.
And 8 to F. Anybody ever saw a number, a hex number when dealing with paint or color or dealing with some kind of address in the computer? Huh? All right. Remember when I went to the color palette? I didn't do that in this class. I'll see if I can find one. All right, let's see here. All right. I don't want that one. All right. So here, class, look. Look at this number here. All right. This is a valid hex number. 0 through 9, A to F. Any digit in here has to be either 0 or 9 or 8 through a F. 8, 4, 5, E, C, 2. That's valid, correct? Now, that's the color. Let's generate again. Okay? Look at this one. This is the color that was here. This number is this color. This number is this color. But all these are hex numbers, but they are what? Valid hexadecimal numbers, right? And that's the color palette, the color spectrum. How you think the Home Depots and whatever can kind of match paint and whatever? Because of the color palette. They find that color that's closely match that color. They match that color to that color palette scheme, and then they punch those numbers in that computer, and then it gives them that color mixture. All right. So that's some ways the hex numbers are used. Hex numbers are also used in addressing. All right, on the computer. All right, but that's your color palette. And normally your color palette goes from what? What's the lowest value in your color palette? Huh? Huh?
That was the lowest?
Yeah. 0, 0, 0, 0, 0, 0, 0. What's the highest?
F.
F. Right? Right? So you're going to be 0 to F. All right, which I think normally is your white to your black. I think black is F, one of the two. But that's your 2 extremes, and all your other colors is mixed in between those colors. All right? So now, back here, all right? So it tells us by default, C++ assume that all integer literals are expressed in decimals, all right? You express hexadecimal numbers by placing a 0x, all right, in front of them, all right? This is 0 and the X, not O and the X, all right? OH and the X. Now, and it shows you an example of how you can actually show it. Octal. Octal is what? How many numbers? 8. What's the valid digits? 0 through 7. Because 0 is the first one, 7 is the 8th one. All right? So octal numbers must be preceded by a 0. All right? 0, not a O. All right? Now, for example, the octal 31 would be written 031. Now, we should be getting, okay, character data, but we talked about, we done dealt with character data because what? Look at this. When I use the data type char, I'm saying I'm gonna represent how many characters?
One.
One character. If I say that and I use char, that one character needs to be enclosed in single or double quote? Single quote. If I use double quotes, that's saying that that could be a string. You understand? It has to be double quotes. So I would, and this all it's saying, I would get an error. If I said char letter, when I do it this way, I won't get no problem. Letter would equal to what? G. But if I had char letter and I did letter is equal to double quote G, close double quote, semicolon, I would get an error because it's looking at it as being more, it could be more than one character. Everybody got that? So you gotta kind of watch that. And when you get in the next level, when like some of my programs, when we're dealing with character data and taking it, converting it, and doing whatever, grabbing one single character, you'll see how it's important to know when and which and whatever, how to use it. All right. So this just showing you a small program, char letter. Letter is A, print out A. Letter is B, print out B. So that's all that's doing. This is a simple program. All right. Another program, simple program. Char letter is what? Letter is what? But remember, what C++ does, it takes 65 and converts it to what?
To the letter A.
To that char, right? So whatever this is, it's gonna find that numeric value and then it's gonna assign it here. So when I output it, if I'm outputting a char, it's gonna output A. Remember that ASCII table I showed you, right? So that's what's happening, right? C++ knows how to distinguish it. So that's why it's important when you're dealing with C++, it's somewhat like a low-level language. You gotta pretty much know what you're doing. You declare something as char, and then you say, okay, that letter is equal to 105, you know, and then you're doing something else with it, and then you're like, well, wait a minute, I didn't want to do this. I wanted an int value, right? So you gotta watch. And like I said, all it's saying is, in memory, it stores 65. So when it prints out a char, it's gonna print out A. If I print out int, it's gonna print out 65, right? So that's all it's saying, and same for the other two, all right? Difference between string literals and character literals, okay? It is important that you do not confuse character literals with string literals. String literals, all right, which is a series of characters. Remember, a string, right? You got a series of characters, whatever they are, numbers, letters, anything you can type can go there. If you're gonna use certain special characters like backslash, you're gonna have to use the what? Escape sequence, right? So, but you can have it all in that string literal, okay? And that all that means, this means that this means that there must be some way for the program to know how long a string is, all right? Now, in C++, an extra byte is appended at the end of a string literal, and that's called a null terminator. And that's an escape switch sequence, and it's known by the \0, the null terminator. Now you say, well, what's the importance of the null terminator? The null terminator is important in that if I try to print out a string that does not have a null terminator on it, then the compiler does not, or the computer does not know where to stop print. It's going to print until it finds a what? Till it finds a what? A null terminator. So I might be printing out some garbage information, right? Because I didn't put a null terminator. I have some data here, no null terminator. Then I have garbage, or some other information, and I'm printing out all that till it gets to what? A null terminator. So what happens is with those string literals, every time you create one, it also appends it with a null terminator to know what? This is the start. Oh, null terminator, that's the end. Okay? Because remember when in your program that I gave, if you type something with a space in it, it's gonna stop at that space, right? But when you declare that string and do that get line, it'll go all the way to that null terminator where you hit the enter key. Alright? So it tells don't confuse the null terminator with the character 0. It's \0. Alright? So it says that if you want to mark the end of a string, however, you use the ASCII code 0. Alright? So let's look at this. If you were to store the word Sebastian in the computer, alright, it would store what? Sebastian along with what? At the very end, the what? The null terminator. It has to, otherwise it doesn't know where it ends. And then when I do see out that variable or see out whatever, it's gonna just run on till it finds what? A null terminator. It could be all kind of gibberish, other characters or whatever, till it get to a null terminator. Right? And you wonder, what's going on with my program? All right? When we get to character data, we're gonna understand that when we create an array, we have to create the array one size larger than the actual what? Value we putting in for the what? Null terminator. If you understand what I'm saying. If I said char, did we do that array in this class? A char array in this class? But if I do char letter and put the brackets 10, all right? That means I have a letter can be a series of 10 characters, all right? What's the maximum number of characters I could put in there? 9. You understand? Because I have to allow for the what? Null terminator, right? Otherwise, I'm writing all the way to the end, but I don't know what the computer don't know where to stop when it at the print the data. All right. So be aware of that. All right. So, all right. It says this: C++ automatically places the null terminator at the end of a string literal. So when we put something in double quotes, it's already there, right? It automatically adds it. So you don't have to add it. And look at this. Char A is in what? Single quotes, right? You don't use a null terminator because it knows that it's only one what? Character, right? When I have a string A in double quotes, it's gonna put A and what? The null terminator in.
So when we do that, the bears program, we have to use the null terminator?
No, because what we said,
Oh.
when you put it, the computer automatically what?
Doesn't.
Right, correct. Now we was doing something like char an array size, then you have to count and make sure you're larger than the size or whatever. Right. All right. All right. So again, same thing with the G. Remember we talked about the char letter and then letter was equal to G. Same thing here. Letter is equal to A, char, single quotes, not what? Double quotes. Because what? Based on looking at this, when I put double quotes on just that single A, I don't have enough what? Huh? I don't have enough space or characters because this is supposed to be what? The null terminator, the number and the null terminator. But when I do it like char, it's saying only one character. You got me? So that's why you get that error. All right. So again, all right, same thing. Char letters A, and then I print out A, print out go down. All right. Now, C++ string class. Now remember I told you in your program you're gonna use string, right? Now when you use string, if I say string school, it don't matter how long it is. It go well, like I told you, up until the blank space. So I could do a CN and it's gonna accept whatever school I put in, as long as it's what? One word. If I have to read in a variable, input with multiple spaces or spaces in it, I have to use the get line. You understand what I'm saying? So, looking at this, if I use the string class, when we say data type, but it's a class because string is not an actual data type that's defined in C++, but you have to use you have to load the string library. Have to. You will get errors, alright? So, string movie title. So now I can do what? Movie title equal. Now, Miss what? Miss who? Eason. Now, looking at this. Movie title equals Wheel of Fury, close double quotes. The computer will automatically put the no terminator. You got me? Right, so you don't have to put it. When you make it a literal, put the double quote, it automatically says, okay, I need to add a no terminator, right? So then you don't have to worry about it when you're doing it that way, all right? Then you can see out my favorite movie is, and then what? Movie title, and that would be what? Wheels of Fury, all right? So let me give you an example of what I'm talking about with those, the string, like the program that you got to do. So, if I do something like this, all right? If I said, well, let's see, let me add string. So now I can use string. I'll say string school. All right? Now, I'll do something like see out. All right, so now, I'm gonna put on the slash. All right, so now I have this. Now I'm declaring school, right? Then I'm saying enter your school name, then you enter the school name, then we're gonna output it. So when I run this, okay, hopefully no errors. All right, enter the school name. Now, I could put BRCC, no spaces, whatever, right? I hit enter. You enter BRCC. So whatever I put in, when I hit enter, it took it at the end of the enter key. But watch this now. I'm gonna just run it again. If I can tell you. All right, when I hit enter, what's gonna output? When I hit enter, what's gonna output? Remember what I said? And then your assignment that I gave, when the second one, when you read in string data and it got spaces in it, you have to use the get line. You understand? What happens is all that other data is left in the buffer, and if I had, let me show you. If I had something like this, and I got to, and I got to go up here and do major, right? All right, so I added that. Now I'm gonna say, okay, now what's gonna print? Well, when I run it, everybody see this, or you'll be able to see it when I run it. Okay, now Okay? I type just Baton Rouge so you won't get too confused. Hit enter. Ah, what happened? Watch what it say. I should have put a flag. I thought I put an inline in the song. Why you entered Baton Rouge? Where is it? Oh, /n. Okay. Well, let me. I'm gonna run it again and do the same thing and let it print out so you can see the process. Okay. So let's get out of here. All right. So I'll type Baton Rouge. All right. Type Baton Rouge. Now, what is it asking me for? The school name and the what? Major. I hear that. What it says? Wait, what is it? Read it. Read line for line. All right. But now look at the top. What it says? Enter your school name. I enter what? All right, but look at that second line. Enter major. Did it allow me to enter the major? Because what? Rouge was still in the buffer. It took Baton and put in schools. It took Rouge and put in major. Everybody understand? So everywhere I had a space, it said, okay, I'm gonna take that and put in there any variable that it asks. And that's very confusing, right? And you'll be home looking at me, and Mr. Buster, I don't know what's going on. What happened? Because in order to read a string with that space in it, you got to use that get line function, right? So now, to rectify this problem, whether I'm going to type in a word for the school or not, all I need to simply do is say what? Right. Put in here, get line, and then CN, comma, school. Right? So all of a sudden now, it's going to get all the way to the end of the line. When I hit enter for school, whatever I type, it's going to accept for school. Right? Then it's going to prompt me for the major. Right? So let's run it. All right? Enter school. Then I'm gonna type it on. Right? Now when I hit enter, what should happen? Right. So you see what happened? Enter the major. I'll say, I'm gonna get an error here, right? If I put two words. Because on major, I'm doing just what? CN. So I'll just say CS. All right? But we would just get computer. All right? Now when I hit enter, Baton Rouge Community College, and then what? Major CS. Right? So in order for it to take that string with multiple characters, I had to use that get line command. Right? Everybody see that? Now that's part of your assignment. Hopefully you're catching on or whatever, or be able to go back and look at the stream or whatever and go through what we going through. But everybody kind of understand what's happening and what I want, right? But now remember, the first program that I asked you to write, I'm gonna take all this out. I'll leave school in there. Well, I'll just comment it. The first program I asked you to write, I asked you to what? To initialize the variable. So what you have to do? For that first program, school equal right? Correct? So that's the first one. You telling it, you initializing it. Data type or the string, the variable, school, and hey, this is the value. And then you go down and say, hello, I'm whatever, right? But you're going to give everything. You're going to give the city. You're going to give the state. You're going to give the name. You're going to give the school. You're going to do all that at the beginning before you do the output, right? But in the second one, you're going to do C out or dependent. C in that get line. I mean, C out please enter. C, get line, CN, whatever. C out, please enter. Get line, CN. C out, get whatever. You understand? And then output. That's the second. Now, so when I run this one, okay, I have this declared. So now all I need to do, I don't need this part here either. Take this out. And I'm just gonna output, you enter. Oh, not you enter, okay. I'll say your school is. All right, so when I run it, see, your school is Baton Rouge. I didn't have to input. I'm not doing any kind of communication with the computer. I'm just running the program. That's how your first program should run, right? All right, everybody got that? All right, questions? Any questions? Huh? I can say y'all always do those assignments, whatever. Now, floating point data, like we said, depending on the data type, you have a larger value you can represent, all right? Just like with int. So that's all they're telling you here, all right? But if you didn't know, like I say, this is a decimal value to 247.91. You could represent it in scientific notation where you have just that first significant digit and then multiplied by the 10 or the negative 10 to the negative 10 to the positive, depending on which way you what. Your decimal point has to float, right? And then we also have E notation, where the E notation is kind of like the 10 itself, but it's just telling you how many places the decimal point will go left, positive or right, or negative, to the other one. All right? Because see, look, this is 10 squared. That's like saying this number times 100. That's gonna move that decimal place here. But then looking at the E notation, you're looking at the number 2, E2. 1, 2, move it over twice, right? So these are the representations of your floating point values, all right? Because sometimes, just sometimes you might get output and you might get it in E notation, all right? Depending on the size that you have for your data type, all right? All right. And like I say, float, double, long double, all right? Kind of somewhat just like int. But then they say float is 4 bytes, double, long double is 8 bytes, all right? So now, look here. Floating point, distance, well first, float distance and then double mass. Because what happens, you're multiplying this times this to get a larger value and you will maybe want a more closer precision. So you change it to double, all right? So, and all they're doing is outputting this and outputting this value, and this is what the results are, all right? Now, this one is in what? E notation, right? So this is what? Plus 11. So this thing is taking this decimal point 11 places to the left, right? Right? And this one, and this one is taking it what? 30 places to the left, right? Because we multiplied this time that number. So, well, no, we didn't multiply it, we just gave it that value. So it's 30 places going to the right, okay? All right, and look, this is the one represented with the 11 spaces. This is the actual value, but the value was represented in what? E notation, all right? So that's all that is. Same thing here, we should be able to understand E notation and what's going on with this, all right? Uppercase, lowercase, doesn't matter. Plus 11, or whether or not we put a plus or not, we still should understand it's E notation, all right? Just like we did the long, remember when we declared the variable to be long int? Same thing, you can do the same thing with float values and have it float it this way, 1.2 float, 45.907, yeah. So you can force it to store it in that fashion, all right? So that's basically what it's telling you here, all right? All right, remember we had the, now, double, then you got the long double. You know it's double because it has a what? Decimal in it, right? So it's not long in, right? It's double because it got the decimal, all right? Assigning, all right? It's almost that time. Assigning a value, all right? Here we go, int x, float f. F is equal to 7.5, I is equal to f. I will only equal to what? Huh? 7, because we can only store what values inside of I? Integer. Integer data. See, look, int and float. Alright? So F is a float value of 7.5. So we're gonna take 7.5 and try to store it in the I, which is integer. But if it's integer, it says, okay, I can only accept whole numbers. Give me the whole number and throw away the rest. Alright? So it will only have that. Boolean values, yes, no, true, false, on, off. So look, we set a value to bool, and then what? We set it equal to true. So now we can only equal to true or equal to false, and then you can do your if based on whatever. If it's true, it's 1. If it's false, it's 0. All right? Everybody got it? Because when we get to if statements and while loops and whatever, we're going to understand that once it processes that loop, it's going to come up with a true or false value, right? Because if what? If x is greater than 5, if we do an if statement, if it's true, we get a 1 result, right? Otherwise, we get a false, which is 0. All right. Later on, work on your programs. We didn't get to assignments. Say assignments and whatever. I think the math operators. Thank you. All right. So what happened is, oh yeah, we need to go over scope. I want to go over scope. All right. We should know these operators, correct? Plus, minus, multiplication, division, and the modulus, right, mister? Alright. Now, alright. So what'll happen is, class, we'll have another class period, and then we'll have a test. Because we're gonna finish covering this chapter. We'll finish that. See, this is the end. But I want to finish going over scope and all that because I want you to understand what and how scope works and all that. Because you can get confused with that scope sometimes. And I think this is pretty much the end of the chapter. But we're gonna go over it. No, that's some more. Yeah, so we'll complete this on the next class period. So I'll see you on next class period. Work on my assignments, all right? Right, class?